Oh, you guys just jump right ahead of me, huh? No patience. Good morning.
Good morning, Professor.
So, welcome aboard, Victoria. Can you hear me, Victoria? Safi, you can hear me, right?
Yes, I can hear you.
Okay. All right. Well, I don't know if Victoria can hear me or not. You can put a chat if you can hear me and you can't talk. Some people do it in places they can't talk. I understand that.
No, hello. No,
Oh,
I was
yes.
having I was having some technical difficulties, but now I'm okay.
Great.
Sorry about that.
That's fine. That you can hear me is a good thing. So, do you have any questions? Did you watch Monday's lecture?
I couldn't find the video. Do you know where?
Okay. Did you read the document that says how to find the videos?
Where is that?
Okay.
I'm
Let me.
sorry.
That's all right. Brightspace is a. How do I say this politely? It's not my favorite learning management system. It's like my least favorite learning management system, but that's okay. You should see the class in a minute, like now. This is learning materials in our class, right? Okay. So you can kind of follow along if you want to. And then right there is view the lecture recordings. And so you go to the home page, scroll down to the bottom, click on the Teams link. Once you're in the app, in the Teams app, which will open separately, click on Files at the top of the page, and you'll see a directory called Recordings. And then you double click on that folder, and you will see the lectures with the dates. And then you click the lecture you want to view. But before you do that, always make some popcorn and stuff because it's great entertainment. Does that help?
Yeah, a lot. Thank you so much.
Sure. That's what I'm here for. So, do you have any other questions? Either of you have any other questions? Oh, yes.
I don't have any.
Okay, cool. All right. We talked about the programming protocols on Monday, and we got through most of them. So you do need to read that because uh, that's there's a quiz that's due by Sunday over the programming protocols. These are really important. These are I've shared these with a lot of people. There are, I think, at least 24 companies in the Dallas-Fort Worth area that use my protocols as their rules for their programmers because my students have gone to work for them and they say, "Why do you write like this?" And then yeah. I actually sent a copy of my protocols out last night to a programming manager that heard about them and asked me for them. So these are not just I made up weird things off the top of my head. This all comes out of 13 years in industry and 36 years of teaching, and yeah, and a bunch of years as part-time when I go out and play like I'm a real programmer. Um, for example, are y'all familiar with the 2000 the great 2000 scare? You're probably not old enough to remember that. Yes, no?
No, I
Okay.
didn't.
Well, let me show you what happened. And this goes along with don't write something that's for one data set, don't write something that's just, a one-shot deal. So we talked about, and you'll hear this, Victoria, when you go through when you watch the recording. We talked about how computers back then, limited memory, limited storage. Storage was extremely expensive, other than tape or cards. Hard drives were hundreds of thousands of dollars. So storage was at a minimum. So when programmers, predominantly COBOL programmers, stored the date, they stored it as month, day, year, which makes good sense, right? It's a good standard thing to do. Problem was when when the computer interpreted this, it was interpreting it as 19-year. Okay. And that worked well. I mean, in the 80s and 90s, that was no big deal. But as the calendar approached the year 2000, what would the computer interpret the date as in January of 2000? 010100, which would be 1900. So we had a bunch of people freaked out, rightfully so, and we had to go in and change that to that. And then that was the easy part. Then we had to go through and write programs to change all the data, all the files. So that was the Y2K problem, because anything that was time sensitive was suddenly going to be 100 years out of date, 100 years ago. And so anything, and so much stuff is time sensitive, like your electric bill. Oh, yeah, and you haven't paid your electric bill in 100 years. So that was the Y2K problem. And it was fun. And it was because programmers didn't consider that their program would live more than a couple of years, if even that. So that was the Y2K problem. And that's why in the protocols, it says don't write a program to process one specific file. They need to be general. And that was a very painful lesson. And I can't tell you the number of 3 o'clock in the mornings I had working with companies to get everything up to date. And we made it. I mean, in the US, we didn't have that much of a problem. One little town up in New Hampshire. I mean, now this is a huge town. Okay. There were like 300 people, and they had one programmer for the town, the town programmer who handled the programming for the electric company, all the utilities, all that kind of stuff. And he retired in like 98, and everything worked fine. Everything worked fine. And then Y2K happened, and they had no power and no water and no utilities. And so they sent in a red team and they fixed it. And so they were only down for probably 8 hours. But it would have been catastrophic if we hadn't fixed it in advance. So that was a real good wake up call, because I was the same way. I worked like I told Safi, I worked for EDS and E-Systems and DEC, and we wrote programs to solve, that were production programs. I mean, when I was at EDS, we were working for little companies, your little organizations you may have heard of, like the Social Security Administration and the IRS, and yeah. So, but nobody thought that their program would live 20 years. I mean, good grief, who thought that? So that's where I learned painfully that you do write your program as general as possible. So the programming protocols is, let me open it. So this is the guy that we write for, Victoria, okay? Notice it's 3 o'clock in the morning. He's been up for 2 days and the system is not running and it has to go into production 8 o'clock Monday morning. And now it's 3 o'clock Monday morning. So that's who we write for. It's called the 3 o'clock in the morning program. And you'll get all that when you read it. It's it's a 41-page document. So yeah, this has evolved. This is the 54th edition of it. But what I want to focus on today is at the end. Hello. Here's the workflow, and again, you haven't heard this yet, but my goal is not to have you write programs that compile and run. My goal is to have you write programs that you can use as part of your portfolio when you go out as a programmer. I want you to become the most professional programmer you can, because it will save you a great deal of time, energy, and 3 o'clock in the mornings. So this is the workflow that you should incorporate after Hello World. I won't talk about Hello World in a minute. Read what the program wants you to do and sketch out the logic on paper. Seriously, on paper, not on screen, on paper. And then once you've divided it into logical blocks, code one block at a time and test it and make it work. And once it's solid, then you add the next piece, the next logical block. Whatever you do, don't try to write everything at once. That's a huge mistake that new programmers make, and that just quadruples the amount of time you spend debugging. And then there's a chunk on testing, so test it, review it, polish it, and add your final comments. Now, as you're writing your code, you're writing the comments as you write the code. Another big mistake people make is, well, I'll put the comments in later. Yeah, sometimes later doesn't happen. And the comments are there to tell you why you did what you did, not what you're doing, okay? And then run one final test. And do that, please, because it's real embarrassing because you'll get it all done. And it's Saturday afternoon. And by the way, for most of our stuff, the deadline is 23:59 on Sunday night, but you should use a functional deadline of Saturday afternoon, because everybody online has their assignments due at 23:59 on Sunday night, which means the system gets loaded. Sometimes Brightspace goes down, stuff like that. So don't wait till the end. And if you use Saturday afternoon as your deadline and you get stuck, get a hold of me. Give it a shot. I might be able to help you before it's done. Do. But a lot of people will look at their code one last time and go, oh, I could just make this little change and it would be better. And then they turn it in without testing it. And then it doesn't compile. And then that's unpleasant. Now, debugging, Safi, did I tell you where the term bug comes from in programming?
No, sir. This is my first lecture.
Oh,
I'm attending.
you weren't here Monday either. Okay. Sorry. Somebody else with a similar picture was here Monday. Okay, so neither of you are here Monday. All right, so this is all new. Okay. Debugging. There was a woman named Admiral Grace Hopper, the only female full admiral we've ever had in the United States Navy. And Grace was amazing. And a lot of people called her Amazing Grace. She was probably the biggest reason COBOL became as popular as it did, because she really liked COBOL. And COBOL was a good early high-level language. So Grace was working as an operator on, and this is back on the Maniac. It was this is the days when computers were vacuum tubes and took up whole buildings. And there were solenoids in the back that were the switches, which we now use transistors for, but they were physical, like a mousetrap. Okay, you'd either close them and it was a 1, or open them and it was a 0. And she was running a program, and it aired out. And so she went in the back and she was looking, and she found that in one of these solenoids, a moth had landed on it. And when it closed, it squished the moth, and it also made it be a 0, even though it was supposed to be a 1, because the moth acted as insulation. So she took them, opened it up, took the moth out, put it in the log book, and said, this program failed because there was a bug in the system. And that logbook is in the Smithsonian Institute. So if you ever get to the Smithsonian Institute and can find the building that's about old computing, you can see Grace's entry with the moth still taped in. In my class yesterday, I had a student who had recently been to the Smithsonian, and she validated that, yes, it's still there, which is cool. It's really good that Grace didn't understand entomology, the study of insects, because technically bugs are the Scarabidae, the shield-shaped bugs, like a June bug or a scarab beetle is a bug. A moth is a Lepidoptera. The moths and butterflies are Lepidoptera. So I'm really glad she didn't know entomology, because it would be really tough to say, man, I can't find this Lepidoptera in my program. Bug is a whole lot easier. That's where bug comes from. So debugging is a big part, and there's strategic debugging, and then there's emergency debugging. And again, read through this. If you have questions, get a hold of me, shoot me an email, and I can answer it in the email, or we can get together here. I am available outside of class. I don't have any set office hours, in quotes, because I've got people that work during the day, and so they can't be here. So yeah, I'm pretty much available. Just get a hold of me and we'll set up a team session. And yeah, so since neither of you have been here, let's talk about this a little bit. High scan, okay? And you can read the preface. Edward Jordan wrote a book on right here, the practice of programming. I'm sorry, no, he wrote programming techniques of program structure and design. He wrote it in 1975. It is still one of the go-to books for programmers. Okay, the guy is brilliant. And here's how he defines a good program. It works according to specifications. It's flexible. In other words, it's not written for just one data set. It's ready on time. It has no bugs. The inevitable bugs can be fixed quickly. It's well documented, executes quickly, and makes efficient use of memory. That's a good program. And there will be bugs. In my whole, since 1972, I have written one program that compiled and ran flawlessly the first time. Okay. One program in the probably tens of thousands of programs I've written. So don't expect it to work right the first time. It just won't. So I grade on this document. This is my rubric, if you will. And I look for the 3 E's. And the program needs to be elegant, which means it's easy to read. That's the big one. When I go out and talk to programming team managers, they tell me, whatever you do, please teach your students to write readable code, because readable code is easier to fix at 3 o'clock in the morning. And you're not going to keep, and again, I'm talking out, when you're a professional programmer, you're not going to keep all the programs you write and maintain them yourself. You're going to move on to other things. And once they get into production, another group of people called the maintenance programmers will take over your code. You want your code to be as easy to understand by those people as possible. Okay? So elegant means you can read it. It's laid out pretty, and that pretty is important. Meaningful variable names, all that kind of stuff. And it can be little things. Now, this is an if statement. It's called a compound if. If index is less than 4 or index is greater than 10. Okay? That works. That's compilable. Everything's happy, except it's harder to read than if you do this. Can y'all see the difference?
Yes.
Safi?
Yes, I can see.
Okay. Do this for your own eyes, for my eyes. Second E is efficient. And students early on will come to me and say, Doc, look, why do I care that I waste a little memory? Safi, do you have a question?
No, I don't. I'm sorry.
Okay. You lit up. Why do I care? I've got, half a gig of memory. Why do I care about wasting a few bytes of memory? Or I've got, on my MacBook, I've got a 6-core CPU. So it's basically 6 processors. Why do I care about wasting a few CPU cycles? And the reason for that is, if you focus on efficient, your code will be easier to understand and will run faster. So yeah. And it seems trivially stupid things. For example, you can declare a variable as an integer. And if you declare it as an integer, it takes up 4 bytes of memory. Or you could declare it as a short integer, and it takes up 2 bytes of memory. Now, if the value of that integer isn't expected to go beyond 32,767, there's no need to use 4 bytes. You can use 2 bytes. So, yeah. And it's little things. And as you go through this, you'll get a lot of efficiency things in here. Okay. And then exact. This is the biggest way that new programmers get in trouble when they start working at a company. So the customer says, okay, I need a program to do X. And the new programmer starts writing the code and says, hey, it wouldn't be hard to make it do Y and Z too. So they write Y and Z into the program, and it does other cool things. And then they turn it in for code review, and their manager says, why did you do that? Take that out. Because A, the customer didn't ask for it, and B, if the customer does ask for it, the company can charge them to add it. So yeah, just know what it's supposed to do. The specs should be there, and write a program to meet the specifications. But again, not just to solve one data set. Now, yes, there is AI out there. And yes, you can use AI to write your code. And when you do that, I will give you a grade of 1. And if you do it twice, I will fail you for the semester. Because this is not about using AI to write your code. Now, there's one exception to that, and that is there's one assignment that actually I give you the prompt to use your AI. And you give your AI that prompt, you take the raw code that it generates, save it, and then fix it. Bring it up to standards, fix the problems. And so you will, that one assignment, you'll submit me 2 programs, one, the original that the AI wrote, and then the one that you made work. So yeah. And And you can read all this because I went over it Monday. You don't need to read it. You can watch the lecture. Variables. This is a big one. Single character variable names. They're not meaningful. Variable names need to be meaningful so that at 3 o'clock in the morning, I can look at the variable, know it's supposed to be stored there. The exception to the single character variable rule is if you declare them in a for loop. So, yeah. And again, I talked about this on Monday. So yeah, I really don't want to repeat myself. So if you have questions about this, get a hold of me. Is that fair?
Yes.
Yes.
Okay, cool. All right. Let's look at another piece. Yeah. Now, I wrote this document a couple of semesters ago because one of the rules is don't ever write a line of code that you don't understand what it does, understand what the return value from it is, because most functions return a value, and understand what the function requires, what you need to give to the function to make it work. So how do you research a function or a library? And we'll talk about libraries too. Read the official documentation. On a Unix Linux machine or a Mac, which is a Unix machine, there's a tool called man, stands for manual. So you do man and the name of the function that you want to use or the command you want to use. And they'll tell you all about it. If you're on Windows, you can use cplus.com or cpreference.com. Both cover C and C++. They're free, and they will give you good documentation for the standard libraries. Then you need to figure out where the library, what library the program is in. And that's going to be your includes, which you'll see in a minute. And then, well, again, what does it do? What does it return? What does it return if it breaks? And what should I give it? That'll save you a lot of time. That's how you research a function, okay? And then write a little program just to use that function, okay, by itself. And yes, this takes time, and this is what real programmers do. And the last step is you should be able to explain it to your dog or to somebody who's never written code well enough that they understand what you're doing. Because if you can't explain it, you don't understand it. Okay? And that's when mistakes happen that are hard to fix. And then so there's a function called stringlen. Okay? So I can type man stringlen, and it tells me about the stringlen function, which counts the characters in a string up to but not including the null terminator. It tells you where it lives. It's in string.h. And then you give it a string. Okay? Which is the name of the string that you had. And it returns a special formatted variable called size t, which is an unsigned integer. It's either going to be 0 or positive. There's no negative number there. Okay. So, yeah. And then you write a little program like this. Okay. And then you write a little program to test it. And then you can use it in your code. Okay. You need to be able to explain it. You need to understand how compiler errors happen and what they mean. And compiler errors will tell you pretty much what the problem is. And depending on which compiler you use, they're really, really good. Some of them are really, really good. I use GCC, the GNU C compiler on the command line, and we'll get back to that in a minute. But it says, there's an error, use of undeclared identifier, and I notice I spelled printf wrong. Okay, printf. So it tells me what's wrong. It tells me what line it's on, what character in the line is wrong, and it tells me what I did wrong. And my compiler actually will put a little caret. It'll print the line out and put a caret under it. Okay. And then look at the line and look around the line. Okay. Because it may be that you missed a semicolon on the line before it, and that confuses the compiler because it doesn't know what line 12 is supposed to do because it thought it was part of line 11. And so, it's stuff like that. And anytime you don't understand what the compiler is saying, look it up. Google is your friend. Read your code out loud. That helps. And this is huge, okay? Compilers generate two kinds of errors. There are what we call syntax errors, which is, well, you tell me, what is syntax?
Like how it's written.
Yeah. The rules of the language that you're writing in. So in German, usually the noun comes first, or the verb comes first. So that's the syntax of German. And there's a syntax to C++. And the compiler will tell you things like, you spelled printf wrong. That's a syntax error. But it'll also give you warnings, like if you have an array, a subscripted variable, a matrix, it will tell you that one of the array indices may exceed the boundary of the array. The program will still run with warnings. But if that variable exceeds the boundary of the array, you'll get something called a segmentation fault, and the program will crash and burn horribly. So don't ignore warnings. And if you're using an IDE, do y'all know what an IDE is?
Yes. Where you write code, right?
Yeah, it's an integrated development environment. VS Code is one. I use Xcode. CodeBlocks is one. If you want to use an IDE, that's fine. But make sure that the IDE shows you all the warnings. And in some IDEs, you have to turn those warnings on deliberately. Show me all the warnings. And I don't know all the IDEs. So I use Xcode as an editor, and then I always compile on the command line, because that compiler will always show me all the warnings. It's very good about that. So that's the last step before you turn a program in, is compile it on the command line. The run command in Windows, or the terminal command on a Mac. Which, looks like this on my Mac. Okay, that's the command line right there. So I can do something like, and it says, oh, there's no file called that name, which I don't have out there. So, but see, these are errors, and okay, that's cool. So that's what the command line looks like. And AI can be helpful, and search engines can be helpful, but be very careful and don't ever copy and paste anything from an AI or the net, unless, don't do it, because probably you don't understand it. Because if you understood it, you'd read it in the first place. So yes, use an AI as lots of people are using AI more than Google now, and that's cool. And Google's got an AI in it now, which is weird, but that's okay. But don't copy and paste anything, please, because it's obvious. And again, if you do that, I'll give you a 1 for the assignment, And if you get 2 1s, I'll fail you for the semester. And that's all I want to say about it, because I know you guys aren't going to do that. So we're good. So that's instructions, again, back in learning materials. That document's out there. Okay. So let's talk about your first. Well, I'm going to run over this real quick. This is the instructions for all the assignments, all in one pretty happy place. Okay. And your first assignment is Hello World, and it's due this week. So, and what you'll find is as the semester progresses, the programs you write will build on previous programs. So basically, you're learning one set of skills at a time. And then once you know those skills, I can give you assignments that use those skills and add new skills. The lectures do the same thing. They build from one lecture to the next. So the purpose of Hello World is to make sure you've got a working ASCII editor. And if you've got an IDE, you've got a working ASCII editor. To ensure that you've got a functioning compiler. And a compiler, what does a compiler do? Do either of you know?
Run the code?
Mm-mm.
Compile the program into the binary or the machine.
Yeah, it translates your program into binary into an executable. So that's what the compiler does. Okay. And so I want to make sure that you've got a working compiler. I want you to know that you understand what's required in the main flower box, which is in the programming protocols. And I want to know that you can upload the program to Brightspace. That's the whole purpose of Hello World. So what do? Copy it from learning materials, and we'll look at it in a minute. Edit it so that you get the right, putting the right flower box in. Compile it, execute it, submit it, and you're done. It should take you maybe 30 minutes. But then I know, and you know, you've got a working compiler, you've got a working editor, and you know how to submit. So everything else in the semester is built on that. Okay. The second program, which we won't do until next week, is playing with files. So you're going to create a little file using an ASCII editor, not in the program. This is a separate file, and you're going to name it file.iotest.txt. And then once you've got that out there, it's got three lines in it, your first and last name, the name of the course, and the name of your program. Then you're going to write a program that will open that file, open another file for output. I don't care what you name it, just don't name it file.iotest.txt, because that'll overwrite my test file. Make sure both files opened, read the data from the input file into 4 different variables and meaningful. You can call them, I suggest, first, last, course, and program, but you can call them what you like as long as it's meaningful. Print the 3 variables to the screen, write those 3 records that you read to the output file, close both files, and submit the program. Don't send me data files, okay? I have my own file, iotest.txt, that I use as the test, when I run your program. And so I don't need yours because I got mine and I know what it's supposed to look like. I know what the output's supposed to look like, so that makes it easy. Yeah, so I'll never need you to send me a data file, but I will require you or ask you to name the test files you create specifically, like in this case, file iotest.txt, because that's what I've got for my test file, okay? So the only time you'll send me more than one file is in the AI assignment that I talked about before. You'll send me the original, the I created, and then you'll send me the fixed version of it. Otherwise, you'll just send me a file, the program. Do make sure that it's a program, not, like VS Code has its own internal file type that it uses, it's got a whole bunch of metadata in it that VS Code needs, for color and formatting and stuff. Don't send me a VS Code file because I can't compile it. It's got a whole bunch of junk in it. So send me either, in this case, send me a .c file. So does that make sense?
Yes.
Okay. So this file and assignment instructions all goes through. I mean, this all the things you're going to do. You got a selection program, a looping program, a rock sort, an array of sorting strings, comparing search methods. This is the AI program, okay? And this is the prompt. Starts right here, and it goes all the way to there. Okay, and you will copy that and give it to your AI. Okay. And you can't use the AI after that. Don't say, now, what did you do wrong? That's your part. Okay. And then you'll parse a file of words. You'll divide a text file into individual words. And then you'll put it all together, or most of it together. You'll read, you're going to read two files. That's file IO. And then you're going to parse it with the parsing program. And then you're going to use the binary search to search the list. And so that this final is putting a bunch of things you already know how to do together. Okay. So that's it. And there's an overview of the logic. So that's what we're going to do in the next 10 weeks. Well, 9.5 weeks. There's one other assignment for the course, and it's called the 24-hour project. And you can do it anytime you want. Okay. And here's the instructions. And it's pretty straightforward. You will spend 24 hours, 24 contiguous hours using nothing digital. Nothing digital. When Susan's my wife. I love her to death. We've been together 17 years, best 17 years of my life. When Susan and I do it, we can't use the refrigerator because it's got a digital display. We obviously can't use the microwave because it's got a digital display. We can't use the stove because it's got a digital display. So anything digital, you can't use it. And again, you can do it anytime you want. I strongly urge you to do it by the middle of the semester. It's not due until Wednesday of finals week, and the course ends on a Thursday. So it's due the day before the course ends. But I urge you to do it earlier. Find somebody to do it with. It's a lot more fun to do it with somebody else. The reason I do this is we live in a world now where we are constantly bombarded with distractions. I'm reading a book right now about why we can't focus our attention anymore. And the reason is because we've got all this social media going on, and we've got computers. Yeah. So this gives you 24 hours where you will be completely free of those distractions, of those hassles. And yeah. So probably 95% of my students make life changes based on this 124 hours. A lot of them in their write-up tell me this is the best assignment I've ever had. I never realized that I was addicted to my phone and most people are. I mean, digital addiction is a real thing. It's just like being addicted to heroin or crack or whatever. When you get a like in Facebook or you get a retweet in Twitter, X, you get a dopamine dump. Dopamine is the chemical in the brain that makes you feel good. It's exactly the same thing that happens when a heroin addict takes a hit of heroin. He gets a dope or she gets a dopamine dump. Okay. It is an addiction. And a lot of people don't realize it. until they do this project. So this is an eye opener for a lot of people. And this has evolved. I've been doing this for 25 years. I guess I should, well, you'll get my background when you watch Monday's lecture. I kind of go over how I got where I am now, but no computer, no digital devices. You can't watch somebody else using a digital device.
What's the situation? Someone watching digital devices?
Computer stop. My Alexa's wake word is COMPUTER. Okay. Can't use a cell phone, smartphone, cordless phone. But keep it with you in case it's in an emergency, always. Okay. But you can't use it as an alarm clock. You can't have somebody use it for you.
What would you like me to do for you?
Computer stop. You can't say to a buddy, hey, I can't say to somebody like my buddy Brian, hey, Brian, text Susan and tell her I'll be home late. Okay, that's using somebody as a secretary. That doesn't work. Okay. And you can read through these. Specifically, devices that are specifically prohibited. It needs to be a normal day. Don't do it on like a camping trip or something like that. Okay. And this one, number 9, I added 3 years ago. I had a Monday, Wednesday, 8 o'clock, Monday, Wednesday class. And on a Monday morning, one of my students walked in and he was wall walking. Do you know what that means?
No.
Okay, he was so drunk that he was using the wall to hold him up and he was walking along the wall. And then he walked down the desks in the middle aisle of the classroom and he got halfway down and he looked at me and he said, no, my buddy's been over 2 gigs of beer on Friday and I've been drunk since Friday and I never missed a bit. I didn't use anything electrical. I couldn't even find my phone. And then he threw up and then he passed out and face planted in his own puddle of vomit. So that's when I added number 9. Yeah. So, yeah, you got to be sober. Now, there are allowed digital devices. My daughter is a diabetic. Safi, do you have a question?
No, sir. Let me mute myself.
Okay. My daughter's diabetic. She wears a transponder on her shoulder that monitors her blood sugar all the time and talks to her phone all the time. I'm not going to ask Emily to not use her medical device for 24 hours. You can use a cell phone if you're in danger. Turn it on. Don't leave it on. Turn it on. Okay. But feeling lonely, feeling sad, feeling out of touch, fear of missing out, those aren't dangerous. Okay. You can use your car. And yes, it's got a couple hundred computers in it now, but you can drive it, but you can't use toll tags, GPS, radar detector, CD player, radio, navigation system, backup cameras, et cetera, et cetera, et cetera. Okay. And church. My church, they use digital projection for our hymns. And I absolutely will never, ever try to get between you and your church, you and your God. So if you go to church, that's fine. Don't worry about it. But in our church, there's a Bible app. I'm a Christian. And there's a Bible app. Don't use that. Okay. Now, our pastor will project the verses from the Bible that he's talking about on the screen, and that's fine, but don't use an app to do it. Yeah. And so those are the allowed things, okay? And a home security system and a heating and AC system. You don't have to turn them off. Just don't mess with them. The AC. The security system, you can arm it and disarm it, but that's it, okay? And if you have a panic button, that's fine if you need it, okay? So that's the 24-hour project. That's the rules. And you're going to write a 3-part report. The first part is the heading, your name, you can read this, blah, 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 and what you did to prepare, okay? And some of these are kind of important, like when Susan and I do it, like I said, I can't use a refrigerator. So I go out and get ice and put it in the ice chest and put what we're going to eat and drink for that 24 hours in the ice chest. I can't use my stove because it's got a digital display. So make sure I got gas for the grill. Um, Tell people beforehand that you're not going to be available for a day. I can't tell you how many times I get in the diary, which is the next piece. Okay. I'll get an entry somewhere between 9 and 11 o'clock. The police came to make sure I was okay because I hadn't returned any of my mom's texts all morning and she thought I might be dead. So let people know that you're going to be off the grid for a day. Okay. And then record what you're doing as you're doing it. Every time you think about your phone, every time you want to play music, every time you want to whatever, every time you want to do a digital device, write down the time, what it was, what you were dealing with, and how you handled it. And if you have thoughts about it, what those thoughts are. This diary is the big part of the program. I'm sorry, of the project. Generally speaking, this project runs between 5 and 8 pages long. Okay. Things you did to fill your time. And again, start and end times. And observations you make. Okay. One thing you're going to discover is everybody in the world is on their phone when you can't be. And then conclusions. Okay. Um, this I want you to do the day after you finish your project. Now, all this diary stuff, that's handwritten, right? In a notebook or whatever. You're going to transcribe it to a document, a Word document, but do that a day later. And as you read back through and transcribe your day, explain your reactions, okay? And the things that you found out, okay? Like not having your person you're talking to checking their phone every 30 seconds, and you're not checking your phone every 30 seconds, you really have what's could be considered a meaningful conversation. Um, One of the standard things I see in conclusions is I got more done today than I usually get done in a week because they're not those handy little slabs of silicon and plastic in our hands are giant time black holes. Um, you find out how much people rely on them. Okay. And you find out how your dependency is. And most students use the A word. They say, I didn't know I was addicted. I need you to do that because you don't know how much time you lose and how much distraction you're living with if your phone's on, if your computer's on, if the television's on, if the radio's on, if the CD player's on, okay? You don't know because it's very, very subtle. And it's taken over our lives. And like I said, I'm reading a book right now on why we can't focus anymore. And it's not trivial. Um, Spending long periods of time focusing on a particular task, we don't do that anymore because your phone, makes a noise and says, "Oh, I got another tweet," or "Oh, somebody posted on my Facebook page," or "Oh, there's something on Substack," or okay. And you don't realize how dangerous that kind of distraction is. Y'all know that you're not supposed to text and drive, right? Why?
Because we get distracted.
Absolutely. Now, do either of you think that you can multitask? That's a big deal. Everybody multitasks, right?
Yeah.
Okay. Safi, do you think you can multitask?
No, I can't.
Well, good for you. Okay, well, I'm going to prove to you about multitasking, okay? So take out a piece of paper and a pencil or a pen. Tell me when you're ready.
I am.
Safi?
Yes, I'm ready.
Okay. And I'm going to tell you when to start, okay? And when to stop. Or you tell me when you stop, okay? I'm going to just record how long it takes you to do something, okay? So the first thing you're going to do, let me get my stopwatch started, okay? The first thing you're going to do is you're going to write the letters A through Z across a line, okay? A, B, C, D, E, F, G, okay? Across a line. And then once you finish that, you're going to write the numbers 1 through 26 under the letters. So you got 2 lines, a line of letters and a line of numbers. I'm going to tell you when to start and you tell me when you're done. Okay, are you ready?
Could you say the letters again? I'm sorry, I couldn't hear.
A through Z. A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. Okay? The 26 letters of the alphabet. And then, the numbers 1 through 26 under them on the next line. Okay? Y'all ready?
Yeah.
Victoria?
Yeah.
All right, go. And tell me when you're done.
I'm done.
Okay. Safi, you done yet?
Yes, I'm done.
Okay. All right, that took you about 50 seconds. Actually, 50.24 seconds. Okay. Now, you're going to do the same thing, only you're going to do it slightly differently. Since you practiced, you'll probably be faster. This time, you're going to, again, write the 26 letters and you're going to write the 26 numbers, but you're going to write A and then the number 1 under it, and then B and the number 2 under it, and then C and the number 3 under it, and then 4 and then D and the number 4 under it, okay? And you've practiced, so it'll probably be faster. So do you understand that this is slightly different, but that's okay. You both understand?
Yes.
Yep.
All right. You mark, get set, go. Tell me when you're done.
I'm done.
Okay. Sophie?
Yes, just finished.
Okay. That took you 1 minute and 10 seconds or 70 seconds. Why did it take you long? Did either of you make a mistake when you were doing it?
Yeah.
Did you feel stressed?
Yeah.
Yeah.
Yeah. Why did it, and you practiced it. So why did it take you 20, almost half again as long to do something so simple? I thought you could multitask. The reason is we can't multitask. Our brains are single thread machines. So when you write just the letters and then just the numbers, it's one task. But when you go from letter to number to letter to number to letter to number, what you're doing is called task switching. And you've got to keep up with what letter was the last letter I did and what number was the last number I did. And your brain has to go from I'm writing letters to I'm writing numbers. And it's called task switching, and it takes more time because we do not multitask if we're using the same part of our brain. Now, yes, you can walk down the street and chew gum at the same time. And yes, technically that's multitasking. But we're talking about a higher level functioning, okay? So if you're studying, or if you're writing code, or if you're doing anything of substance, and your phone is there, and you notice, oh, I got a new, a new post on my Facebook page. You're going to multitask, and you're going to task switch, and you're going to lose time. So, and the same thing happens when you sleep. If you sleep with your phone on, oh, please don't do that. So what I'd ask you to do, and just for me, just while you're writing your code, put your phone in another room and turn off the announcements for that period of time so that you can focus on the code. Because we don't multitask. And you've just proven to yourself that you can't multitask because our brains don't do that. Okay? What does that mean to do?
No, it's okay.
I get all kinds of ugly looks in class when I do it in class, my face-to-face classes. Because yeah, we can't. I can't. And one of the few times that Susan has gotten angry with me in the last 17 years is we were talking about this, and she said, "Well, I multitask all the time," because she's the customer service manager for a leather company, an online leather company. And I said, "You can't." And she said, "Yes, I can." So I had her do this. She said, "That wasn't nice. You were being mean to me." But it's true. We don't multitask. We think we do. We just task switch really quickly. And truth be told, computers don't multitask either unless you've got multiple CPUs. And even then, they don't multitask very well. What they do is the same thing you do. They task switch. The thing is, they run 1,000 times faster than we do, so you don't catch them task switching, but they do. The one time that you'll see this, where you can really see them doing that, is if you're trying to like edit a program and run backup at the same time, then your computer will slow down. And that's because it doesn't multitask either. It does task switching just like you do, except it does it really quickly. So yes, we don't multitask. Okay. So that's what part of what the 24-hour project does. And again, you can do it anytime you want. Just try to make it a normal day. If you work and your job requires you to use a computer, talk to your manager. Most managers I've found historically are think that this is kind of a cool thing to do. And so, like, for example, I've had a number of students who are cashiers. And so for that day, instead of being a cashier, they stocked shelves in the grocery store or whatever store they worked in. So they didn't have to use a computer, which was cool. So you pick the day. It does need to be one consecutive 24-hour day. And if you look at the rules, technically it's only 15 hours because you can sleep for 8 and nap for 1, because naps are a big thing. They're good for you. Or at least for me, I'm a napper. But so it's really only 15 consecutive hours without a computer. I suggest you do it that way. I suggest you start the project when you get up in the morning, stay up for 15 hours, and you're done. That's the easiest way to do it. So, yeah. It's interesting, and I think you'll find it very interesting. And then I've also got out there is it there or there? Oh, it's here. I've got a sample of oops, wrong thing. I've got a sample of a well done 24-hour project. Okay, and it's not here right now. So I'll have to put it in there. I really love Brightspace. It loses things all the time. But I'll again, I'll put a sample out there that was really well done. And so it'll give you an idea what I'm looking for. I expect that you'll spend that you'll have probably not more than 5 or 6 minutes without thinking about on your digital devices. I'm concerned when a student submits like, noon, I started doing the dishes, 4 o'clock, I finished the dishes. No, sorry. So yeah, that's a 24-hour project. And I'll mention it a couple times, but I want to look at Hello World now, because this is the first program that you're going to use. And I will show you what Hello World looks like. Okay, so here's Hello World. And this is Xcode, okay? So this is out there. You copy and paste this, okay? And then you're going to edit this to be the proper flower box. And I'll go back and show you that. It's a very huge, long program. It does a printf, which is print formatted to the screen. And it prints a new line, 2 tabs, the words hello world, a new line, and that's it. And then you have return 0, which is returning control of the operating system. Very hard program. Don't write your own, use this one, and then edit up here to make it conform to a proper flower box. Okay. Now let's do it line by line. Anything that starts with that character, which is properly called an octothorpe, not a hashtag, not a sharp sign, not a pound sign. That is an octothorpe. If it starts with an octothorpe, it's called a preprocessor command. What that means is that will be done before the compiler gets control of your code. Okay? So, anything that starts with an octothorpe and include says, I want you to add this library of functions to the compile. So the compiler now has a place to get things it needs for standard input and output, STDIO, standard input and output. Okay? And they end in a .h. The .h says they're header files or library files. Questions? Anytime I say something that doesn't make sense, stop me, please. Okay? So you're going to have a bunch of includes. When I program professionally, I include 2 libraries that I wrote myself, and that's beyond the scope of this class, but you can write your own libraries. And there's a bunch of standard libraries, and we'll talk about more of them as we need them. But that STDIO will be in every one of our programs because that gives us the input and output tools. Then we have main. Main is the function that is the program, okay? And functions have a type. In this case, main is an integer. Okay? It's type integer. We know it's a function because it's got a name followed by parentheses. If you see something with a name followed by parentheses, it's a function. Almost everything we do in C is done in a function. Okay? Main is a function. It has a type. Okay? Does that make sense?
Yes.
Yes? No?
Yes.
Then we have the open curly brace. Or if you want to be formal, the French brace. Curly braces include enclosed blocks of code. Functions as a, pretty much always functions have a curly brace that starts the block of code and a curly brace that ends the block of code. Okay? And one of the rules is that curly braces are always on their own line and the open and close vertically align. Okay? That's huge. Most of the code that you see out there doesn't follow that rule. And that's a gigantic problem at 3 o'clock in the morning. One of the, and I'm repeating myself from Monday, but one of the big problems that we as programmers now have with these cool, fast, wonderful computers is that we can only see about 30 lines of code at a time. We're limited by the size of our screen. And yeah, I know that there's some monitors that are rotated 90 degrees and so you can see more than 30 lines of code, but most people don't have those. Most of us are limited to this kind of a display. So if I've got a block of code and I want to know where it starts, I can, if I follow the rule, I can put my cursor on the closing curly brace and just strictly scroll straight up and find the corresponding open curly brace. Okay? Make sense?
Yes.
Okay. Victoria?
Yes.
Okay. So main is a function. Is this a function?
That would be something inside the function, right?
Does it have a name?
Yes, it
Yes.
is also a function.
Is the name followed by parentheses?
Yes.
Is it a function? Yeah.
Yes.
Yes, it's a function. Now, printf is a function. It says print formatted. Okay, it's one of the, in it by default writes to the screen. Okay, so it says take this string, this set of characters, and send them out to the screen. And the /n is, like I said, it's a new line, so it does a carriage return line feed. The /t is a tab, so it tabs over twice on a new line, says hello world, and then prints 2 blank lines, and it's done. Things in C end in semicolons. Okay. Where do you think this function comes from? Hint, hint. Where do you think printf comes from? Where does that function live? Because I mean, somehow the compiler's got to know what it does. Where do you think it comes from?
The studio library. That's there.
STDIO, yeah, standard IO. So printf lives in standard IO. What happens at compile time, because I've included that library, when the compiler sees this, it says, okay, I know what that is. And it takes the compiled code for printf out of the library, plugs it into my program right here, and then passes the data, the new lines, the tabs, the hello world. Okay, puts that in as well. So that's why we include stdio. Is this a function?
Yes.
You sound so positive about that, Victoria. Absolutely. It's got a name and it's got parentheses. This function returns control from the program to the operating system. We pass it a value. It needs to be an integer value because it's an integer function. It returns a value to the operating system. If that value is 0, that says everything worked just fine. If we return a value other than 0, it says something broke. Okay? So 0 is success. Anything other than 0 is a problem. Now, what do I mean returns control of the operating system? When a program begins to execute, the very first thing it has to do is capture the current state of the operating system, because it's going to take over and own the CPU. So it captures the state of the operating system. It then begins executing. When it finishes executing, return restores the state of the operating system to the way that it was when the computer took control, or I'm sorry, when the program took control. Because if it didn't do that, as soon as the program ended, your computer would crash because it wouldn't know what to do. So that taking control and returning control happens invisibly, but it's a lot of CPU cycles. Okay? It's around, depending on what CPU you've got and what version of it is, it's between 33 to 50 instructions on both ends. Okay? Now that's invisible to you, but it's there and it's happening. The same thing happens when you write your own function, not using libraries, functions from libraries, but you write your own function. So I strongly encourage you not to write functions because they incur a great deal of overhead, especially if they're a single-use function. And I'll repeat this multiple times this semester. We'll get more into it as we go. Okay? But this is hello world. Excuse me. Zoe's telling me there's somebody at the door. I'll be right back. Yes, ma'am. Shout, Zoe. What is it? Good girl. What? That's that. Oh, good girl. Yes, good girl. Yes. Oh, good girl. Scary mailman was here. Oh, that's terrible. Oh my gosh. Wow, yes. Oh, dear, dear, dear. The scary mailman came right to the door. Oh, and you chased him away. Such a brave puppy. Such a brave puppy. Good girl. Yes. Watch. Yep, the evil mailman, the scary mailman, came right to the front door. Oh my gosh. And Zoe scared him away, so she did her job. Zoe's a mountain cur, and she's my girl. And I also have Narwhal, who is a Russian blue, and he owns the house. He's a cat. And then I have Max, who sits over my right shoulder, and she's an African gray parrot, and she has a bunch of language. She uses words. And I have 4 chickens and 3 hives of bees. So that's my menagerie. Okay, back to this. So this program is really only 1, 2, 3, 4, 5. Scroll. 6 lines long. Everything else is comments. And the compiler ignores comments. Okay, that's real important. So all the stuff in here that's green, the compiler never sees. It totally ignores it, doesn't increase the size of the executable at all. So that's cool. Comments don't cost anything as far as the size of the executable. Questions? No? Okay, cool. So that's your first program. You're going to copy this from learning materials into your IDE or your ASCII editor. And then you're going to fix this, okay? Because there's a lot of parts missing, and we'll get over that. Oh, sorry. No. No, this one, yes. I'll throw that one away. Hi. And we'll throw this one away. And now I'm not running tight anymore. Okay. Sorry about that. The computer was running tight on memory. I ran out of application memory. Oh dear, oh dear. Hello, go away. You're still out of memory? Okay, and I'll make you go away. This is what I mean about multitasking. Oh, cancel. Can't do that. How about this one? Make that go away. Yep. Now are you happy? You're still not happy. I gotta keep Outlook. Keep messages. Matt Keeper, I'll make that go away. I don't need Acrobat. I don't need the calculator. Oops. I don't need the calendar. This is weird. It doesn't happen very often. Still not playing. Interesting. Hello. Come back. Can you guys still hear me?
I can hear you.
Okay, good. This is weird. Zoom US. I don't need that. There's a shut Brave down. Huh. It's acting like something that's sideways. It's still not letting me close this. I'm not taking up that much storage. All right, I'll quit Claude. This is strange. I have not seen this happen before.
I'm I'm not a Mac user, but do you need to like resume all of the paused ones?
Let's try that. I don't need notes. Now you let me put now. Okay, good catch. Okay, I don't know why it got memory bound, but it did. Okay, so any questions about the general format of a program? You're going to have your preprocessor commands here. They can be included in the body as well. They always start with an octothorpe. You got your int main, your open curly brace, your return, whatever you want to do, your return and your close curly brace. That's about as simple a program as we can make. Now, have either of you had other programming classes?
I took Python.
Oh, I'm so sorry. Safi?
Yes, took a data science class. It was also in Python. And
Oh,
also a
did
Python
you?
course.
I am so sorry. Python is such a horrible language. Because it does so much for you and it writes such absolutely hideous code. Okay, one of my jobs is gonna have to, I'm gonna have to unhabit you. I'm gonna have to unteach you some bad things that you probably learned because Python encourages you to be bad people. Yes, I've written in Python. I've written in 51 languages now, but I don't like Python. Anyway, this is the general form of a program. Did you, when you took your Python class, write Hello World as your first program?
Yes.
Yes, and it was, I think, just 2
Good.
lines.
You know why? Why does everybody start with Hello World? Because Ken Thompson and Dennis Ritchie, who are the fathers of the Unix operating system, and we're not going to get into that. I actually wrote a book on Unix, but they wrote Unix. Dennis Ritchie wrote C to rewrite Unix in a mid-level language, and they were getting it up and getting it running. And Ken was sitting at breakfast that morning, and he opened the funny pages back in the days when there were real physical newspapers and cartoons. And there was this cartoon of an egg, and then the egg cracked, and then a chick popped its head out of the egg and said, "Hello, world." And he thought that was extremely funny. So the very first thing that Unix ever put out was the string "Hello, world." And so every good programming class starts with Hello, world, just in part to pay homage to Ken Thompson and Dennis Ritchie. And I talked to them a bunch when I was writing my Unix book, and Dennis has passed, and the world lost an incredible programmer when Dennis died. But they were interesting people. So anyway, that's why we do Hello World. So any questions about this assignment? Because I'm going to open another file that we can look at. It's got a little more meat to it. Let's see what I'm
So we only have to copy paste it, or do we need to change something?
You cut and paste it, and then you put the correct flower box in. Oh, but what's the correct flower box? Good question. I'm going to high scan through programming protocols because I went over it, like I said, Monday, but all right. Oops. Every program will have a main flower box to start the program. Okay. That's a rule. And the first thing is the purpose. Why was the program written? Then the name of the program. And your program names will start with your first and last initials. So Victoria, your program will be VB Hello World. And Safi, yours will be SM Hello World. Okay. I do that because that way, if you have a question about how I graded it, I can find it. If everybody calls their program Hello World, then I end up with a directory full of Hello Worlds. And it may take me days to find out how many, where yours is, because I've got multiple classes and I've had multiple classes, and yeah. So that's what your program name will be. And anything that's anything that ends in a colon is required. Okay. How do you invoke the program? How do you run the program? On a Mac Unix machine, it's ./a.out because the compiler by default generates an executable called a.out. On a Windows machine, it'll be program.exe or whatever your particular compiler generates as an executable. Okay, so that's what you need to put here. How you run the program. Then you list your variables. There are no variables in Hello World, so that'll be variables : none. Okay. Otherwise, you'll have what variables you used, and then what functions you called. And this is only for functions that aren't part of a standard library. So for Hello World, it'll be functions none, because printf is part of stdio. So that's a given. Okay. So don't put, like printf and scanf and all that kind of stuff in here. Not to include header files. Then who wrote it, when they wrote it, what modifications were made to it, and there you'll put in what you change. And you fix the flower box. And you put the date in your identifier, your initials are you, and then special notes. That's if there's something special conditions that the program needs to run, like the input file has to be sorted, or the input file has to be in the same directory as the program, or whatever. If there are any special notes, that's where you put them. Most of the time it'll be none. But you have all those headings. Okay. That's the main flower box. And you'll have that in every program you submit to me. Okay. Now, this /* starts what we call a comment block. And it ends with an */. So everything in between this and this are comments and completely ignored by the compiler. Okay? So you'll add that to Hello World. And you will have this at the beginning of every program you submit to me. If you have functions, please don't, but if you do, they also have a main flower box. But there's additions, like how instead of invocation, you'll put in how you call the function. Okay. So this is what you add to Hello World in your editor. And then you compile it and you run it and you send it to me. Does that help?
Yes.
All right. Let's look at something more interesting. Oops, wrong one. This one. Oh, well, let's show you what I do. CC is the C compiler, the GCC compiler. The GNU organization. It's an online place you can go to get code, and compilers and stuff like that. GNU, the GNU animal, looks like a muskox, stands for News Not Unix. But yeah, that GCC is the standard compiler. So what this has done is it's taken what's in Hello World 3, turned it into an executable. Okay. Now the executable by default is a.out. So if I type in a.out, which is the invocation, it says Hello World, and it's done. Okay. Questions? It's pretty straightforward. Now, so that's Hello World. Let's find something that's more interesting. Interesting program. I need to find something fun. Okay. This is a more complicated program, and it doesn't have a flower box in it. This is just a sample for class, okay? So here, I'm including, or the student's including stdio, and main is an integer function, and the includes the I of int for main, the open curly brace and the closed curly brace are the only things on the left margin. Well, and targets of go-tos, but we haven't gotten there yet. Okay. So that's the left margin. And then I'm declaring a string of characters, 5 characters long, called word. And I'm declaring a string of characters, 5 characters long, called word2. And then I printf. Now, are these functions?
No.
No. They have a name, but they don't have parentheses. They have square brackets. Printf is a function. We know that. Okay. Is fgetS a function?
Yes.
Yeah. You sound so confident, Victoria. So this reads from standard input, which is the keyboard by default. Printf writes to standard output, which is the screen by default. And so I output that, I output word, and then I print so what, and then I read word2, and then I print word2, and then I return 0, and I'm done. Very, very complicated program. So let's see what that looks like. fgetS example 2. Oops, it's not there. What did I call it? Oh, example. Okay. Okay, looky there. What is this telling me? It's giving me warnings. Okay. It's saying, hey, whoa, now be aware that you're using the format %x, which is dumping in hex, and it's a string, so you maybe want to consider using %s instead for this variable. Okay. Same thing with the other printf. Now, my compiler doesn't like me to print things in hex. So it gives me those warnings, and that's fine. And I say, yes, and it's in line 9 and 12, and I say, that's cool. I understand what you're saying. I'm not worried about it in this case. So let's run it. And okay. So here it is as a string, and here it is as hexadecimal. Okay. So that's what it does. Now, in learning materials, down, where is it? It's here. Here is the ASCII table. Okay. ASCII stands for American Standard Code for Information Interchange. All right. I strongly recommend that you download this and print it. Or in the programming protocols, there's a link to a table similar to this that you can download and print. But I need you to have this hard copy next to your keyboard every time you code. Okay? Now, what is the American Standard Code for Information Interchange, and why do I care? It's the bit pattern the 8 bits that make up each byte, each character that I can use in writing programs or running programs. Okay? So, and why is it the American? I mean, why did we get away with, why is it the American standard code? Why do I need a standard code? First of all, let's make that easy. Why do I need a standard code? Okay. Why do we need to all speak the same language if we're going to communicate?
So we are all on the same page and understand what others are trying to say.
Exactly. So all the computer companies need to agree that some particular bit pattern represents a letter or a number or a special character or a non-printing character, but everybody has to agree that that same number of bits represents the same thing, or we have chaos. Okay. Now, there are other standard coding mechanisms. There's EBCDIC, which is 6-bit instead of 8-bit. But pretty much everybody uses ASCII. So, and I'll get into that. There's a document out there called Why Converting from One Base to Another, or Why God Made a Mistake and We Really Should Have 8 fingers on each hand. So let me give you a quick example here. Okay, let's look at the letter A, the uppercase A. Okay, it's decimal 65 or octal 101, and you can ignore the octal field, okay, because we aren't doing the octal. Octal is base 8, and we're doing base 16. But in hex, it's 41. Now, why do I care? Well, and I'll get into this more, but I'm just going to show you. Oops. That's binary, okay? Base 2. That's 1 byte, 8 bits, okay? And being an old fart, I would much rather see 41 than 1 okay? So I can convert each half of a byte into 1 hexadecimal character. And it's a lot smaller and a lot easier to represent. And hex is the truth, okay? So if I go back to the ASCII table, a whole lot of these characters in this first column, they're control characters, okay? They are what we call non-printing characters, okay? So everything in the first column is non-printing, and space is, space prints as a space, but these don't print as anything. I can't print them. Okay, when I try to print them, I get nothing. So if I suddenly get output from my program that's nothing, I can print it in hex and see what it is. Why I got it. Okay? So we're going to spend a lot of time on this table. And we're going to spend a lot of time talking about how you convert from uppercase to lowercase or lowercase to uppercase. So yeah, print this guy. Or in programming protocols, there's a prettier one that you can print that's got color. And well, actually, I'll show you that. Oh, I am here. Okay. Cosc. Do-do-do. This has been a work in progress for a long time. Let's make it easy. Oh, wrong thing. Don't need that. There. Okay. Here's another one that you can go to www.asciitable.com and you can print this. And see, this is all pretty because it's in color. Okay. But since this is proprietary, I can't put it in my programming protocols. And you only need to worry about the first page, the first 128 bytes. Okay. The second half, the second 127 bytes is special characters, graphical characters, all the special letters that some languages require, you know, with umlauts or whatever over them and stuff like that. You don't have to worry about the second half because we're probably never going to see it. We're definitely not going to use it, but do print at least the first page, so that we can refer to it in class and you can just look, you know, to your left or right because it's right there next to your keyboard. But that's a big deal. And understanding this is a big deal. And I will spend time in lecture explaining how we convert from binary to hex. And hex is a beautiful thing. Converting from decimal to hex or hex to decimal or binary is a pain in the butt. But decimal to hex, I'm sorry, binary to hex and hex to binary is mechanical. And we'll get into that later. But do get this, you know, go here, print it. Life is good. Okay. Questions? Okay. Well, that's a lot for one day. So that I think that's probably enough for one day. Do you agree?
Yes.
Now that you were sure about. I have been told that listening to my lectures is kind of like trying to drink out of a fire hose. And I understand that. And I agree with that. But we have 10 weeks to do 16 weeks worth of work. So we got to hit the ground running and run like big dogs. Okay. So you're going to spend significant amount of time outside of class. General rule of homework, if you will, is that you should expect to spend an average of 3 hours outside of class for every hour in class. Okay. So that means we're going to spend 4 hours in class a week, and you're going to spend 12 hours minimum outside of class doing homework. Okay. Reading the protocols document, reading research instructions, reading about, finding out about how functions work. Yeah, so, okay. And again, I'm available. Send me an email and we'll meet and I'll start a team session, send you the link. We can meet one-on-one. I'm delighted to do that. So I'm available and we'll figure out a time when we're both available and we'll get together and I'll answer your questions, look at your code, whatever. Okay. So,
Um,
yes.
I wanted to ask, I was trying to look up the recording for the class, and I tried and do the instructions of the file, and I can't seem to find it.
All right. That's what I was told was how we do it. Let's
Or
see if I can do it with you. Your Teams. There it is.
thank you.
Sure. Okay, that's that. Okay. All right, so here I am in Teams, right? Yes. And oh, maybe they changed it to shared. Let's see what shared is. It's different than it was. And this is not cool. This is not the way it is supposed to be. I click on this. It should be in Teams. Okay, so I click on Teams and I come down and I find us, okay, here. And I click on that. God, it used to have library up here. Okay, I'm gonna have to get with Settle and find out, and I'll send an email out as soon as I know. Maybe it's this one. Is this one? No. Oh, this is weird. Teams changes all the bloody damn time and it bothers me. I'm sorry. Click on the plus. No. Page. No. Posts. No. General. No. Huh. Manage channel. No. This. No. I don't know. This is what it worked last semester. So I don't know. I will get with
Okay.
CTL and wait a minute, what's down here? More apps? No, it's not that. Gosh. This is weird. Okay, that's not it. Something changed there real quick for a second. Oh, that's weird. Okay, I'll find out. You're right. It didn't work. And that's what they told me it was
Okay.
supposed to work. But I will send an email as soon as we get done and figure out what's going on.
Okay,
And I'm
thank
sorry.
you.
Wait a minute. Maybe it's no, it's not here either. Okay, I'll find out. And I will put out an email as soon as I find out when Settle the group that manages Brightspace gives me back a message. Okay. Thank you for pointing that out. Because like I said, I know another way we can do it. Hang on a minute. I know another way we can be sneaky.
I see
Here?
one recording. I'm sorry.
Where do you see it?
In the shared tab.
Okay. Another way we can do it is open chat. And there's the recording. Okay. In the chat. So that should, I think, that should, I think it's supposed to be, because when I save it, it shows it saved here, and I saved the Monday recording. So where did you find it, Safi?
So in the chat, there's a tab called shared,
In the
right
chat?
next to the post, like in the channel that you made for this class. Not in this meeting chat, in the main
Oh,
channel
okay.
that
But in Teams,
Teams, yeah.
right? I'm going to put you over here, and we're going to go do that again. Okay, so I'm here. I go to the class. And in shared, you said?
Yes.
Shared. Oh, no, that's,
77. I think it's 1420.
yeah, 1420. Oh, this is 2025. I'm sorry, I clicked on the wrong one. It's same color. Hang on, let me go back to Teams. It's 2026. 2026. Here we go. Okay. Here. Now that's spring. Here. No, here. No. Here. No. Where did you go? Where's summer? God. Oh, I really don't like Teams.
Where it says maybe join now button is.
Oh, up here. Yep. Good. Thank you. Okay. So I click on that. And now I go to shared. And here's recordings. Okay. All right. And that's from Monday at 10:53. That's how you get there now, Victoria.
Okay, yeah, I see it. Thank you.
All right. Thank you for pointing that out, because I didn't know, because I don't ever do this. So, okay, cool. So then you can watch it right there. You're also supposed to be able to watch it see it in the chat. But anyway, now we can find it under recordings right there. And when I stop recording today, it will also show up there after about, it takes about 20 minutes to save it. Okay. Thanks, Safi.
Okay, thank you.
You guys rock. All right. Well, you guys have a blessed day. I'm going to stop sharing. And you guys have a blessed day. And I will see you on Monday. Get a hold of me if you have questions between now and Monday. Okay.
Okay.
Sure.
Thank you. Have a nice day.
Thank you.
You guys have a blessed day. Thank you much. Bye-bye.